Hey guys, welcome to my YouTube channel. Please do not forget to like and subscribe to the channel so that you don't miss out on any future videos and miss out on all the fun. So in today's video, we are going to take off quantities for this simple structure. Now, as we can see, our structure is a 9,380 millimeter by 7,395 millimeter structure. And we also have two different types of walls. We have a 270 millimeter cavity wall that runs on the external perimeter of our structure, and we also have it here as well as an internal wall. The second type of wall is our 220 millimeter wall that runs internally. The second drawing that we are going to look at is that of our sections. That is, we have our section for the 270 millimeter wall, and we have a section for the 220 millimeter wall. Now, our 270 millimeter wall has a 700 by 300 millimeter deep footing that is made up of 15 MPa / 19 millimeter stone concrete. And our excavation depth is going to be 700 millimeters, and that is because from natural ground level to the underside of our footing, we have a depth of 700 millimeters. Now, from natural ground level to the underside of our DPC, we have a height of 350 millimeters. Now, I need us to note that our foundation brickwork is going to be from the top of our footing to the underside of our DPC. So that means that to get that height, we would say 700 minus 300 millimeters, which will give us 400. And then we're going to add that 400 to the 350 millimeters to get our foundation height for our brickwork as 750. Now, from the top of our DPC to the underside of our beam filling, we have a height of 2,950. Moving on to our 220 millimeter brick wall, we have a 620 by 300 millimeter deep footing made up of the same strength as that of our 270 millimeter wall. Our excavation depths are going to be the same. The only difference that is going to be there is that of our foundation brickwork height and our superstructure brickwork height, but we will put those down in a short while. So I would advise you to put down all the measurements that are relevant to the item that we are dealing with, and that is our foundation brick wall. So it's going to be 350 plus 700 minus 300, okay, which is going to be 400. That means that our total depth, or total height of our brickwork, the total height of our brickwork is going to be 750 millimeters. And then for our superstructure, for the 270 millimeter cavity wall, it's straightforward. It's going to be 2,950. Now the DPC for our the superstructure height for our 220 millimeter wall is going to be slightly different. As we can see here, our guide tells us where our 220 millimeter DPC runs, okay? And if our superstructure brick wall starts from the top of our DPC to the underside of our beam filling, right, that means that the superstructure height for our 270 millimeter wall and our 220 millimeter wall is going to be slightly different. So for our superstructure, for the 270 millimeter wall, our superstructure height is going to be 2,950 millimeters. Now this is if you want to be pedantic, all right? And then for our superstructure, for the 220 millimeter brick wall, that means that we are going to deduct 85 millimeters from 2,950. And this is because, or it's 85 millimeters because one course is 85 millimeters, all right? So yeah, our superstructure brick height for our 220 millimeter brick wall is going to be 2,950 minus 85, and then we get the superstructure height for that. And it also means that our foundation height as well, or depth, is also going to be slightly different. That is, to the 350 millimeters, we are going to add 85 millimeters, right? To the 350 millimeters, we are just going to add 350 millimeters to get our foundation brickwork height. I hope that I haven't lost you there. I think it's pretty straightforward. Yeah, of course, right? So it will be 85 millimeters plus 350 millimeters, which is here, plus 700 millimeters minus 300, which is 400. Okay, therefore our total will be, it's just slightly different. It's not a big difference really. Yeah, so that means that our foundation height for our 220 millimeter brick wall will be 835, and then for our superstructure wall it will be 2950 minus 85 millimeters. So 2950 minus 1/4, which gives us 2865. We're done. Okay, we have extracted all the necessary information that we are going to need in order to be able to do our collects. All right, great. So first things first, when we get to our collects, we start with our 270 millimeter brick wall. For the sake of reference, we'll refer to that as A, and then, yeah, let's go. 270 millimeter cavity wall, or cav wall in superstructure. We said it's 2950 millimeter high, right? Great. So this is where things get a bit more interesting. Now we know that as per the standard system, our brickwork is measured in square meters, right? And the only thing that we have so far is the height of our brickwork, right? So now what we need to determine is the mean length of our structure. And we're going to do that by using the centerline method. Now, there are various other methods that are used, like the long wall, short wall method, but for the purpose of our example, we are going to use the centerline method. So I would like for us to go back to our floor plan. Okay, now, like I said, we are going to use the centerline method. The first thing that we are going to do is determine the total external perimeter of our wall. Okay, so we have that 9,380, and then we're going to refer to that as horizontal walls. All right, so we will have 2 times 9,380. Okay, so that covers these sides over here. The one thing I would advise you to do is to always shade in your work after you have put down a dimension, so that you do not make the mistake of double measuring your work. So we're done with the horizontal side. We are now going to put down the vertical side, 7395. No, I'm sorry. Let us deal with all the horizontals first. Yeah, but those are the only ones actually, so we're done with it. Let's go to verticals. Okay, vertical. Now for our vertical side, like I said here, what we're going to do is we're going to measure the external perimeter as is, and then we make adjustments afterwards, right? So 7395 multiplied by 2, so we will have 2 times 7395. Great. And then the second thing that we are, and then we have this internal wall as well that is running vertically. So it means that we are going to say 7395 minus 270 on either side. Okay, 7395 minus 270 on either side, and that gives you 6855. 6855. And then we're done with our verticals. All right. So now what we are going to say is total perimeter or total berth space. Okay. Total berth will be equal to the sum of our horizontal walls and our vertical walls for the 270 millimeter brick wall. Okay, that will give us an answer of I hope I don't make any mistakes because 40,405. Okay, so now that we have found the total girth, that is the total external perimeter of our structure, we need to make adjustments, right? So in order for us to be able to make those adjustments, we are going to use the following formula. 4 multiplied by twice times half the breadth, which in this case is 270 millimeters, which gives us, I'm going to put this in brackets so that it indicates that we are going to make a deduction. It gives us 1080, right? So our mean girth, or our center line, is therefore the sum of our total girth minus 1080, and then we get to an answer of 39,325. So we put that down there as 39.33. we round it up. Okay, we're done with our the superstructure brickwork. For reference purposes, we're going to refer to the second description as B. Okay, so it is going to be 270 millimeter curved wall in foundations, and we determined the height as let's just go back to our sections. We said our height is going to be 750 millimeters. Great. Collects foundations 750 millimeter millimeters deep. Okay, so we are going to say from a 39,325. So it's 39,000 or 39.33. We're getting to another interesting part. It's quite interesting, but yeah, it's quite interesting. So we're going to refer to that as C, and then we start concrete in footings. Size 700 by 300 millimeters deep. Okay, great. Now we refer to that, say from cancel merge and center from B. Oh, sorry, from B we had 39,325. Now remember what I said when I talked about how when using the centerline method you need to pay special attention to points where you have junctions, where you have cross walls, where you have intersections. This is the first junction that we have where our external 270 millimeter wall meets our internal 270 millimeter wall, and then the same scenario there as well. And then here in these cross walls you have our 220 millimeter wall meeting up with our 270 millimeter wall on this side and also on this side. So now we're going to need to make adjustments where our 270 millimeter wall meets our 270 millimeter wall, and then the adjustment for these junctions here we will make when we get to our 220 millimeter wall. I just want to quickly show you what happens where we have junctions. Okay, now bear in mind I'm not an architect, I am not a civil engineer, so I'm just going to do the best I can do with the limited knowledge that I have of this app. Right, so we are just going to draw lines, thick lines for our excavations and concrete. I just want to show you what happens, right, and why we actually need to make that adjustment. This is concrete for our horizontal walls, okay, so that's the first one. And then the second one, we would have it from here, going that way. Oh, sorry, escape. Just undo that line. Yeah, coming to this point there, to that one there, and then to here. And the next one is this one here, to there, we have it there, we have that there, we have that there. Great. And then we have that, we have that, we have this here, and then we have that there, and then we have that there. So that is basically it. That's what we have for, let's just use a different color to shade it in. That is what we basically have for our concrete. All right, this is for our horizontal walls. Let's quickly do this. Okay, let's quickly do this. Okay, now we're going to do it for our vertical walls, and I want to show you where the over measuring now comes in. Here we go. First things first. You see, there we go. We're measuring it again. No, there we go. Measuring it again. Oh, sorry, I'm even making a mistake here. Let's undo line. Undo line. Yeah, let's just start from the beginning. There we go. You see? We'll add it again. Okay, so you see we have measured it twice basically. Okay, that is here on this point here. We've done it again. We are doing it again. We're doing it again here. Same thing happens even there. Okay, there we go. We just remeasured it again. Okay, now these lines are just throwing me off. Okay, so from that point to this point. There we go. There we go. There we go. And you see, we have measured it again, measured it twice. So that's why we need to make an adjustment. I hope that now we understand it thoroughly and that there are no confusions at all. Now these corners here are not regarded as junctions, so we just ignore them. Alright, so yeah. Okay, first things first, we will need to do this. Deduct junctions, okay? Or let's just say it's adjustments, I don't know. Right. So our footing is 700 millimeters, right? So you subtract 270 millimeters, which is the thickness of our brickwork. That leaves you with 430. And then from that 430, you divide it by 2, because what we are trying to determine is I'll just see if so you say 430 divided by 2, which gives you 215. Now these junctions happen twice, so we will have where 270 meets 270. It happens 2 times, sorry. So you have the product of 2 times 215, which gives you 430. Therefore, it means that from 39,325, we are going to subtract 430. Okay, so we come up to the minus 430, and then it comes to 38,885. 38,895, okay, which gives us 38.895. 0.90. Now the length for our excavations in concrete are the same. Let's just put down the description there. We will refer to it as D. So excav for footing, size 700 by 700 deep. And then we will say from C 38.895. So we have that as 38.90. So working out the perimeter for our 220 millimeter wall is pretty simple. Yeah, so we're going to say 9,380 minus 270 minus 2,000 minus 270 and then minus 270 this side. Let's just put it down there. It's 9,380 minus 270 minus 2,000 minus 270 and minus 270, which gives us 6,570. So it's 6,570. We'll put that down there as 6.57. We're done with that. And the following thing is the following thing we need to do is EF. It's our brick wall in foundations. So 220 millimeter wall in foundations. And then we said that the foundation depth is going to be 835. So in foundations, 835 millimeters deep. Great. Make that reference from E 6570. It is the same, so we don't need to do any adjustments there. Great. We are done. Now we get to the interesting part again, where we need to make adjustments for our concrete. Yeah, FG. So we have concrete in footing, size 620 by 300 millimeters deep. So we will say from F to 6,570, and because those intersections or cross walls, we need to make an adjustment for those. So go back to collect, and then we DDT 700 minus 270, which gives us 430 divided by 2, which gives us 215, and we have that intersection occurring twice, so it will be 2 times 215. So it'll be 2 times 215, and then we have 430. Okay, so we will basically have sum 6,570 minus 430, which is 6,140. And then we put that down as 6.14. Great. Now we get to our excavation part. Excuse me. Go to our excavations. H Okay, sorry, excavate 414, size 620, and then our depth there is 700 millimeters deep. And then we say, oh sorry, and then we say from G, which is 6140. We have 6.14. And then that is it for our lesson. I really hope that whatever it is that you didn't understand, you now understand. And if you have any questions, do leave your questions in the comment section, and I will get back to you as soon as I'm able to. Thank you.